The next hour, there will not be a developer talk, so maybe that's why so few people show up. Though we talk about a solution, and okay, it's animated. I hate it. So we will talk about how to manage OSGi solutions in the field and how to create a manageable, upgradable device, basically. And that's my colleague and partner, Mr. Hott from Process. So he will do most of the talk, but I have the honor to do the introduction. So I will set, safe harbor statement, sorry. I will set the framing basically. So where does it come to play? Where does it work on? And then Mr. Hott will talk about the technology itself, the features, and then we will have a demo if it works, hopefully, a short fun demo about what it does, and we have a few conclusions. So the Internet of Things, I'm sure you have seen a lot of the keynote and other slides, so there's a lot of framing. So I will give you a very concrete definition where this fits in. So the Java technology is very wide, and I will more give you a framing where this specific solution fits in. So this you have seen. So we're talking about the big Internet of Things, the cloud of embedded devices, whatever you call it. And the basic strategy is to push intelligence down the stream to the edge as far as possible to migrate an easier adoption of M2M in the market, basically. That's the main goal. And at the same time, and that has nothing to do with what Oracle does, this is just happening in the market. People understand that they can't continue to use their classical approach to M2M, which has been highly verticalized, and it's usually like this. Every company, maybe together with one of your few partners, does everything themselves. And if you really want to scale within a company or with your solutions or outside of classical M2M companies, you have to come up with a horizontal approach. And you have to kind of make more use of reusable components to propagate this out to the customers, out to the field. So that, as again, this has nothing to do what we do, but it's connected somehow. So we believe we have a strong play in helping this play, which anyhow is happening. So the biggest picture, the highest picture, I think, from the advantage a Java-based solution has for this is that in a real M2M, you have many complex points. So it starts with a device that can be dumb or a bit smart or very smart. Then usually you have a gateway. You have a middleware that basically is the M2M middleware. So it's not the classical middleware, it's a middleware that manages the M2M stuff. And then, of course, you have your backend system where you finally make your money from. So, and to have a continuous platform there allows you not only to push data and connectivity, that can be done without Java. But with Java, you have the chance to push down logic down to the edge. So you can decide whether you want to do all your preparation and work here, or here, or here, or here. And at the end, you might want to decide to put there, and there, and there, and there a bit. If it's Java, you can reuse the code, and you can push it and later decide where you want to deploy it. And of course, there might be different devices. So one of the examples, one of the customers I work with is large car manufacturer in Germany. And he has, of course, different classes of cars. So he has cars which start with $30,000 up to something like $400,000. So, of course, the IT in his car is different. The high-end cars have much more performance and power, so he might want to do much more logic in the car itself to give more comfort, to give more functionality. While on the cheap, I mean, I know, 30,000 is maybe not cheap, but on the relatively cheap, he might just want to collect and, you know, gives the comfort back to the cloud and make everything happen there. So with this model, he can actually reuse the code, because he can decide later where to put the code and where it runs on, if you use a horizontal platform like Java. And that's the major idea behind it. So for this specific topic, if you also want to allow client application, you can do this, what I call the game changer or the phase change. So you go from a very verticalized, optimized solution, you go over to what is a service platform. And that's actually a shift which happened in PCs around the 80s, when DOS came up. Suddenly people wouldn't have CPM and other stuff, they would have a standard operating system, a write against it. And then again it happened around the 90s when Java EE showed up. So people went from enterprise applications, which were usually written in their own language or in C++ or whatever. It was targeted for their own stuff. And then Java EE showed up. It wasn't the most pretty solution, not the most fastest, but it had the wonderful advantage that it did run on many different devices. It had a few features that everybody needed, and it allowed developers to actually think about developing business logic and not application logic. This is the same thing which I strongly believe will happen in the whole embedded market, and especially in M2M. And there are some areas like with Java and OSGi in this smart gateway automation devices where this is already happening. So this is relatively far in the curve of adoption. So this is then what a smart device, a real smart device would like, not compared to a smart meter, which is really dumb. This is a real smart device. You put in a Java application layer an OSGi container that basically allows you to deploy applications, remove them in management, and that will be the second part. And then you have the message queue or web services or the data sync. That's actually in the connectivity layer. So you need as well a connectivity layer. And then the developer can actually totally focus on this. And he doesn't really need to care about this anymore. And what I've seen from customer projects is actually in this part, 80% of the work is done. And only 20% here. And that is not really helpful if you want to be fast to market and you want to address a great many use cases. So, Mr. Hott?
Yeah. Okay, thanks very much. Okay, first of all, welcome to the show, and I'm sorry there are only so few participants, but because I think I got really something exciting to tell and something, yeah, so a lot of people will miss it. Anyway, I hope they look it up later on. I'd like to introduce my company to you, first of all, so that you know who we are talking to. We are a company, a German company, that has been around since 1997. And since 1999, we focus really sort of on something like the search of the Holy Grail, which would be basically a reference, standard-based open reference architecture for the entire M2M space. And when we started off with this fairly ambitious goal, people were telling you are crazy. Today, I think we are nearer to this point than ever before. And we are right now, my company's got 120 employees. Most of them are technicians. I am and two of my colleagues are the only guys doing marketing and sales, because usually people know us and they have a certain need for open, neutral service platforms and the other products which I'm going to introduce to you. We work very closely with Oracle, because that's obviously all our technology is Java-based, and that's basically also what I'm going to talk about. First of all, I think an open reference platform should always be as brutally standardized or following standards as possible. My company has been very active in the OSGi. We've been the first, I don't know, who knows the OSGi? I think it's well known, right? Who does know the OSGi? Raise your hands. No? Sorry. do you know who knows the OSGi? Okay, so then I'll be brief. The OSGi is basically an alliance of very big companies. I think we are the only ones who are on board level and have less than 30 or 40,000 employees. The goal is to really define a standard service platform originally for the smart home. That's why it's called OSGi. It was called Open Service Gateway Initiative. But right now, this technology is also used in a lot of different vertical markets, like automotive and so on. Another standardization body, which is very important for the smart home, is the HGI. The telcos are really afraid that a similar thing happens to them in the home market that happened to them in the smartphone market, where they are right now just a bit pipe and other people are doing the business. And there are many other standardization bodies, but I don't want to bore you with too many details here. The overall principle here, and that's kind of what not everybody has understood so far, is that in the entire M2M world, it's all about apps. Yeah, it's all those use cases in the end are apps. And what we have now realized, and there has been a steep learning curve from the smart home market, is that it really works if you have an open platform, you give out SDKs, and you tap the creativity of thousands of developers. Because, I mean, in today's world, hardware is not so important anymore. It's just, how to manage apps outside the smartphone world. So how do you manage them in cars, in smart homes, in e-health environments, smart grid, and you name it. And all they really need is the right infrastructure. So they need a certain platform where they are hosted, where they find their home. Yeah? And obviously this has to be found in the local area network, like a smart home or a car. Then it has to have the right backend infrastructure, and that's actually the focus of my talk today. And you have to have an SDK, which you give out to developers so that they can easily start developing applications without worrying too much about generic features like security or manageability and so on. And that's actually what we do. And I just like to really talk a little bit about the project. We have a name, and maybe it's not the best name. It's called mPRM. It's called remote. What is it actually remote?
Resource management platform.
mPRM. It's called mPRM. Yeah, managed resource management platform. Yes. Before I really go to this piece, which is on the right-hand side, I give you a picture, more concrete picture out of the smart home world. What we typically have in a smart home is, first of all, obviously a gateway. If you see this picture of the gateway in the middle, this is a gateway that comes from Sumitomo and has been used by Deutsche Telekom for their project, which is going to be launched early next year. So this gateway, on the graphic here you see, is above the operating system. You have a Java virtual machine. In this case, it comes from Oracle. You have the so-called OSGi platform, which comes from Process, my company. And on top of that, you've got all these apps. The connectivity is very important in this case, obviously, to the end users, that they can see and control their applications from anything, from their mobile device, from their tablet, from the TV, from the PC. So there's a connection there, and that's part of the infrastructure. And on the left-hand side, you could imagine a lot of devices you've got in the home. So, the washing machine, actors, switches, thermostats, whatever you have, cameras. The picture was too small to show some of them, but what's really important is that all these different devices in today's world are connected by various wireless and wired standards. And that's the first problem. And when you talk about connectivity and about smart home, I would say 80 to 90% of the people focus on this issue. And this issue has already been solved. We've, together with other companies, have developed kind of an abstraction layer which allows you to add new protocols. So it doesn't mean whether you have wireless protocols like ZigBee or Z-Wave, or you got wired protocols like KNX. That's a sort of a power line standard. And more importantly, this thing is scalable. So if you have a proprietary protocol, or if a new protocol is coming up, like right now we've got N-Ocean, I don't know whether you heard about it, another wireless standard, which I think is very good. So that's the connectivity on that side, and basically what you've got in your home. And on the right-hand side, it's basically the entire backend management system. And now, after having showed you this concrete example, and again, this could also work for a car or for some other environment, I'd like to show a more technical picture here, which again shows you what's on both sides. I mean, on the service gateway, you have what I was just talking about. I don't want to talk about too much more about it. It's basically based on this Java virtual machine and the OSGi framework, the functionality I just described. And on the right-hand side, we now have the backend system. And the backend system, that's sort of the first news, is actually the first enterprise system that has been really based on OSGi itself. Because we as an OSGi company, and formerly we had our own J2EE application server, which we have sold to SAP back in 2000 to fund what we've got now. You see what's part of that backend, and obviously it's the OSGi gateway management, the software repository, the app store, and you see more below, you see the end user who's got access to the app store via again, various devices, typically a smartphone or PC. And on the right-hand side, you see the administrator who can manage the functionality of the backend. Now, the backend system itself is very modular, consists mainly out of those components. So apart from these mPRM users have got there, the system, you've got backend service support system, J2E application server, payment billing, as you can see. That's all stuff we obviously don't do ourselves. This would be a little too much, and that's where we are very happy to have got Oracle, because they allow us to really offer, or we offer this together, a real scalable and efficient backend infrastructure to our customers. This is sort of the main slide, is kind of an overview on what this remote device management can really do. It's really there as a management and monitoring system supporting remote device maintenance, software provisioning, and service operation support for all sorts of network-connected devices. And also supporting a lot of various standards also for the connectivity. What it, in a nutshell, can really do is a centralized device configuration management, software management and provisioning, and automatic software compatibility and dependency resolving. It can monitor the status and performance of the devices in the field. You can remotely diagnose problems, you can troubleshoot problems, and you can control, obviously, the applications that are installed on the gateway. Again, this is a glimpse at all the packages. The whole system is built up, as you would expect from an OSGi system, in a very modular way. So not all companies need all of the packages, but this is, again, an overview, and I will not just read this to you. As you know, this presentation would also be available to you on the website. But let me just look a little bit closer to the various features. The management operations is obviously, the reason here is to manage the software deployment. So you can really group the devices in various groups, and you can filter them, and you can really manage the way you want to execute an update, for example. And that's very important, because as long as you have a few hundred devices in the field, it's fairly easy to manage this. But if you really got millions of devices in the field, you really want to be more precise and more efficient in updating them. And you choose any criteria. You can say, I now want to update any devices that have the JVM version 2.0. Or you could say, I just want to update everybody who lives in Ohio. You say, I want to update anyway, you can group them and you can do this as you want. What's also very important in the real world is that if you do the installation, and you can do the installation anytime, not all the devices might be online. Yeah? So a car might be in the tunnel, somebody switched off his device, which is more unlikely, but you really can follow and track the progress and the outcome of the installation. And there's a persistent queuing, so really make sure that the installation works in a secure way. And by the way, I forgot to say this, we've got really many companies who are really relying on that software. So on this picture I showed earlier with Deutsche Telekom, they are working with our remote management system and many others as well. The software repository, obviously also very important to manage centrally the database and to do everything that basically keeps this efficient. So part of it also to manage the dependencies, I can read all the points to you, but you can imagine that this is a giant task if you have millions of customers and they're everybody's using 20 different applications with a lot of bundles. But this is something that we are able to manage also thanks to Oracle. We just now do a kind of a benchmarking in the Scottish labs of Oracle, and I don't know how many devices we will be simulating there.
20 million.
20. That's right now. The target is 20 million.
Gateways, not devices. Gateways.
Exactly. So I think that's also a message, because this is not the future. This is something that can be done, and it can be done in a very secure way. The user management, obviously, very important as well. You obviously have to manage the way the companies log into, the end users log into their gateways, and the whole user management and group information and basic profiles of the users are and what kind of devices they've got and so on are easily controllable by this feature. Other features are things like security, which, as we all know, is very important, especially in the smart home. There's a lot of discussion about how secure is this really, and so there are very generic, very good features, and they can obviously be always extended. Right now with Deutsche Telekom, we have a lot of work just on the security, but Telekom is also happy that they are able to use what we've already got off the shelf. The other thing, which is, I think, a really big advantage, is that this remote management system is very modular and can be itself very easily be integrated in other backend systems that are already there. I think that these are sort of the main features. It's obviously a lot of more, and I invite you to go on our website and have a look. There's a very extensive documentation on what this product is really able to do. I think at this point, it really is kind of an enterprise kind of thing, and I would very much invite Rainer to talk about the last couple of slides while I try to prepare the demo. Thank you.
Yeah, so from a technology perspective, the mPRM is basically a Java-based application that can run on a standard Java VM or can be run concurrently with a Java EE application if you want. Itself, it's OSGi based, so it's extremely modular. So you can actually run it parts on different machines, and you can also extend it easily. So if you see here, try with the laser pointer. Okay, so here you see the different modules, and all of them can be run separately. Of course, I mean, it needs to store content, so it needs a separate machine which runs a database. And then it has a Java connected architecture or a Java MNS based connectivity to the enterprise world. That's what you would expect. So it's a very typical Java backend application. So in a small deployment, your laptop would really suffice for this. You need roughly 1 gigabyte of RAM. You would use maybe a MySQL database for a store, and you just deploy it. And then you have everything on one machine, and you can just log in and as an administrator or an user and start to manage your, maybe 100 devices. That's actually what you see with small management. And as Mr. Hott already told you, we are at the moment at the EXA labs. So you're all Java guys, I think. So you might not heard about the EXA Logic. That's a huge machine, Oracle cells. It contains a Java EE application layer and also a database integrated. And it comes in small, means I don't know, 60 CPUs or something. That's their small package, and then it scales up to, I don't know, 254 or whatever. And then you get this kind of architecture. So you would build a typical enterprise large-scale architecture where you put different components on different parts. And of course, you would have your database cluster, basically, usually separated. And then also you would have service gateways. So you would separate the communication to your client also to separate things. So originally, before I did the client Java stuff, I came from the enterprise side, so the Java EE side, and that's a typical web service architecture. And it scales identically how you would scale a Java EE. You put web services on the client as a proxy or gateway. Then you have your Java EE with the enterprise applications. And then you have your database world. And it's really scalable. So what Oracle and Process do together at the moment at the EXA Labs is really to prove to Deutsche Telekom as a customer that we can really, on basically one EXA cluster, manage 20 million devices or gateways. So each gateway in itself in this test will have up to 100 dumber devices connected. So that's really a huge architecture you're building up. Of course, the devices are actually emulated. At the moment, you don't find 20 million devices out there. So you have another cluster which emulates the client traffic. And what we do is basically we take the OSGi client, virtualize it, and then let it run and reconnect a great many of times. And then you try this to deploy applications, update them in a field. And so it's not only a normal scale test, it's really a user test. So now, after this preliminaries comes the real part. That's the demo. So, Mr. Hott, are we?
Yeah, thank you very much. Can everybody hear me? Yeah, I mean, the demo is basically really the whole scenario we were just showing in a demonstration. And let me first of all show you what kind of devices we've got. I think we try to simulate sort of a customer who's at home and he's now linking into an app store of some service provider. And maybe I will switch over to the next one. And so if he gets in there, he basically gets this web page here. So that means he's got, first of all, to log himself in. That's something I've already done. Then he has sort of various options. He can see sort of, here you can go into the App Store and can see these are all the applications that are in the market. Some of them he has to pay money for kind of surveillance services. There are alarm services. Then, the idea is here that the service provider, once he bought this, he subscribed to the service, he got some services for free, and then he sort of gets a voucher code in here. And then, basically, when he's choosing, or let me explain first of all what kind of devices we've got here. We've got, first of all, a gateway, which, can you see this? Probably not so. It's a gateway, and this has two USB sticks. That's for ZigBee and for Z-Wave internet connection, wireless connection. Then he has here two switches where he can, for example, attach two lamps to it. And then this here is a thermostat, which is that way connected, which you can also buy anywhere. And you are going to switch this on now. It's already not working. Maybe let's. Rainer, you have a look. We can't really show in the time. We can't show all the use cases anyway. To make sure that I don't forget anything, I also have I have kind of a little PowerPoint here, so I can more systematically get you to all the demo features. I think what I've already said is I got all the hardware. Basically, the service gateway registration is something I've already done as well. This is being done in registering with a certain code. So now we are logged in and we can start using the functionality. Now we would say we try to connect these devices. So let's say we've got these devices from our service provider, and now it's obviously the next step is to pair those devices to connect these devices to the central gateway. And this is being done in taking this code. This is the voucher code, and put it in here in the voucher space. And I'm trying to just copy this. It makes it easier. So here we are, and we enter this. The code is accepted. And now we can start with the process of pairing. So we go now to the home application portal, which is basically here the service gateway. And by the way, the whole thing is a little bit slow, but the server for this demo is located in Germany. So all this goes to Germany and back. Now, we have now the user goes to the home application portal and opens now the ZigBee settings. Actually, that's already the first problem. The ZigBee settings should now be there. If the whole thing has been connected, let me just check. Did I do something wrong here? I think it was accepted. Oh, sorry, I just forgot now to go to my applications. And I then have to install the application, obviously, first on the gateway before. Well, that's a bit difficult before I continue. So the application is now one of those two free applications I was showing before. It's now the basic ZigBee light control, which is this one. I got a bit of a problem here. And I go now here on the install button. It says, do I really want to install it? I say yes. Now the ZigBee is working, and the next thing is obviously that I have to pair the devices. No. Okay, how do I do this? I go back to my service gateway. And now, finally, here are the ZigBee settings. I just put it, and now I can start the pairing process. And I just go, and actually, for the end user, who knows the system even less than I do, there is also a help desk here. So he would say, dear customer, so it tells me what I have to do. First, please press the start pairing button. This will put your service gateway into pairing mode. Then go to your device and press the corresponding button on it. The device should appear in your browser. Repeat, the last step should be stop pairing. So we know what we've got to do now. We push the pairing button. And we've got to go to the devices. And as long as they're not paired, they blink, as you can see. Now I have to push this button on the side for a little while, and then they should pair. Now it's green, you see, these lamps are already switched on. This pairs a little bit longer. Okay, now I know everything's working, and I can see these lamps also here on my, whatever it is. This time it's my PC, could also be my mobile phone. And I can also then put them off and on. That is typical for a demo. Maybe do it the other way around and try to. I think what you should do, you should not have these lamps on as long as you pair. Sorry about that. So we're going to do this again, and we stop the pairing for now. And we remove the devices. Yeah, I think I will do the following. I try to go back to the hope this works this time, otherwise it doesn't look so good. Okay, one more time, never give up. It doesn't want to do this. Yeah, okay. One more time. Okay, so keep your fingers crossed, otherwise I'll show you the thermostat. So, start the pairing again. Again, they are blinking orange now. Okay, I've never seen them be red. This one is green. Let's hope it works this time.
So one is on at least.
Okay. So again, the two are on here, so let's check whether I can now remotely get them. So you see, okay. So you can switch them on and off. And now what we can do, the next step would be, we've done all this. This picture is correct. And I could now also, how much time do we have? I could also connect the thermostat, but maybe we just leave it because we skip the thermostat because that's the principle is the same. You go and link the server. You have to do the Z-Wave settings because the lamps are now connected via ZigBee. This thermostat would be Z-Wave, so you have to do the settings. You have to pair those devices, and then the thermostat would appear, and this would look basically like this one. So you have the thermostat, which and you to pair it, and then you have the thermostat, where you can control the temperature. And if you obviously get the temperature up or down here, it's paired with the thermostat, or if you manipulate the temperature on the thermostat, it's obviously shown up here. Now, the next thing we could do is having a look at our apartment. So I have a little apartment here, which looks like this. Where is it now? And you can now set images for every room. You can also do insert pictures, and and then place your devices in the room so that you exactly know where those devices are. This is done. I think. No, that's what we've done. Again, it's a little bit slow because of this server. Normally, you should have below here. You should have the. You can create certain rooms. Yeah, you can say basically kitchen. Create this room. Then you can have now various pictures attached to the room. Let's say I accept here this picture for my kitchen. And now this would be again my kitchen looks like this. No, sorry, I've got to be back in the room configurator. So here we are again. Now you got, this is the kitchen, but I should have a different picture now. So it should be the room configurator. Okay, what I could do, let's imagine, I just feel a little bit puzzled that this is not showing up. Now I go to the, let me. So now I can drag this room into the corresponding room like this one, and I can now extend it so that it fits in here. And once I've done this, I can go into the room.
That's really the slow internet connectivity.
Yes, I'm very sorry. Now, actually, the picture of the room should appear, but let's say I just add the devices first of all to the room. I add the two switches we've got now. Or let's say you can also edit this because otherwise it gets confusing. You can also just call it switch 1 and 2, but let's just edit. So I have the first switch in the kitchen. I can, let's say, add the second switch in the kitchen. And now I'm sorry that this is not working, but you can imagine that you now have the kitchen picture in the background, and you then can then place those switches wherever you want to place them. Let's say, you know, you don't you can basically drag and drop it. Oh, here's the second one. That's good. So you can maybe see I have one for the ceiling light. You know, I have one just, you know, when I get into the door. And you could you then also add? You could say this is the door, you know, and this is switch. Switch ceiling. And then you can just place it. And then you can, you know, basically go in there and you can say, I want to switch it again on and off. Should actually work. It's really slow, but again has to go to Europe and back. Okay, so this is, we skipped now the thermostat demo, but I think you got the idea. Then there's also another app. You can basically go back to the App Store, and you can say, now I just found a nice app, and this app is called One Power Off. So you just go there, try to find it. Where is it? Who helps me here? One Power Off. It's not there anymore. No. Home alarm. Do you see it, Rainer?
No, it's not there.
Today is not my day.
Somebody removed it.
Where is it?
No, it's
Have you seen it? This one. This one, right? Okay. Yeah, that's the one. Okay, so I install it. Okay, so now it's obviously installed. I go back to my service gateway. How do I have this now?
System try applications.
So now I have my applications here, and I basically go to this application here.
I think you have to go down there.
Oh, sorry, I have to go to
this tray.
Hmm? Yeah.
Takes a while to load.
Yeah. Good, we got 9 minutes left. So now this is basically the home, and actually we should have now a picture on the right-hand side. we can put it off and on, but I think it's basically this
yes.
one, right? So I go on this, and if I push the button, obviously all the power is off. Okay, and you can imagine that basically we have a similar application for the for the thermostat, where I basically can control my thermostat and control the temperature from wherever I am. So this is actually what could be shown as well. And since the thermostat is not on yet, I just have to show you this little picture. Once you have the thermostat on, you can also download a scheduler. Danfoss is the name of the manufacturer of this thermostat that you can very easily control to any heating that you have in your rooms. So you have 4 time zones, and you can basically just say, what kind of temperature you would like to have on what time of the day. I think that's quite a useful tool, and that's also something you can do with that. So I mean, this just us a few applications, but I think it shows you the basic principle, what's really happening. And it's very similar, you will agree, to what we find with Apple and Google. You just go to an app store, you have a lot of applications, and this is really, you can really tap the creativity of a lot of people who know those applications. Because what I found that is many service providers, especially telcos, they don't really know how to do applications. They're not in the market. Yeah? So this way, a company specialized on e-health or on energy control or on security can just have the best app, offer it on the app store, and the people can buy it from there. And we are finally out of this thing where you need one box for every service. So this is in a nutshell the outcome. And I don't have any more slides.
Yeah, I have just a summary slide. So I want to emphasize, of course, this is a very simple demo, but it gives you the idea that you can transform a solution or vertical problem-oriented focus into more a platform focus, where you then go like, I mean, I've great many customers, somebody do heating controls. So I will approach them with this solution and basically tell them, until now you are an expert in heating control. So these things on the wall where you make lights and things. With this approach, you can basically generate one platform for all the problems. Or you go to somebody who has, I don't know, steam management. I have a customer who does steam management for large factories. So every motor is tuned differently. And with this, they create a platform, and then they can deploy. So this can be an open platform, like in home automation, but it can also be a semi-closed platform, like in industry control. And the difference is that after you have the infrastructure, you don't approach it in a way that says, so that's my problem, how do I build it up, how do I do this, It's like, okay, this is my infrastructure I already have, and then how do I create an application? And of course, the final application will be much more complex than what we've shown, but it gives you the basic idea. And actually, if you have this infrastructure in place, your development time for the projects, they will shrink dramatically. So that's what I call the 80-20 switch. So you go from 80% setting up your infrastructure and 20% business logic. You go to 20% setting up your infrastructure to 80% business logic. Well, that means you're faster to market, and actually your applications or your infrastructure will have much higher value. So you're competing better because either you're faster, or if you are as fast as the other guy, your solution will be just much more complex and so more attractive to the customer. So that's about it. I think we are in time, and I think we have, if you want, a few questions. Yes? Yes. So the biggest project we have at the moment is Deutsche Telekom. And in this case, actually, the first prototype is based on an ARM processor. However, they don't actually care about this because the developer never sees it. The developer sees only Java. So they will, if they go in the next step of their RFQ, the typical thing in a telco to do, they do a prototype. I mean, a prototype with 50,000 boxes. And then they will go in the large-scale deployment, and they will, basically do an RFQ to hardware vendors. And then, I mean, I've had customers, same thing with MIPS-based, PowerPC, x86, whatever you want. So it's not dependent on the hardware, really. And it leverages this. So the applications Deutsche Telekom has at the moment, they're around 400. So they have around 400 applications. So Process has I think 10 for a demo purpose. You can download the GDK from Process. There's an EVA license and actually create your own solution very fast. It's very simple. So.
And how many customers are using this type of services? You're providing this?
No, we are not a service provider.
You're
Yes, yes.
Customers have they?
So they are starting now. So they announced it. What
Yeah,
is?
maybe I can add to
Yeah.
that. I mean, there are just two of those projects in the market right now. The one is Deutsche Telekom. The second one is here AT&T. They go together with Cisco. But again, this technology is pretty new, and I can only tell you that we are right now talking to at least 2 dozen of other people. We're doing demos for them. They have Spanish Telefonica and a few others have already issued RFQs for this kind of infrastructure. So this is really making, as I said before, the HGI, the Home Gateway Initiative, where all the major telcos are organized, has specified this as a new standard reference architecture. So we at Process, I would say, work with, again, maybe at least 2 dozen more people interested, a couple of RFI on top of it. But what's also important, this is really the whole ecosystem. This is not just the service provider. If you go to the chip and the people who do sort of smart home or telematic hardware, they have discovered that they rather show their hardware with this kind of service platform on top of it than just showing it without it, because this kind of service, this kind of hardware that just provides connectivity so far becomes an intelligent service gateway. So we have a lot of projects also in telematics space. There is the top-notch car from Audi right now. It's using this platform because and does energy management, especially that's one of the features, because it's a electric car. But they are really, I can, write me a mail and I'll give you all the details. But there are also device manufacturers, and we got at least 30 device manufacturers that use our software to connect their devices, like, for example, Miele, a German developer of white goods. Many people who do home automation, like ABB, they have a company in Germany called Buschjäger, Eaton, to name one here, and Claire Controls and a few others, Alert Me, and you name it. They obviously go away from their proprietary hubs in the home and work with OSGi, just because it's more scalable. And that, I think, is also the main trick here, that it's scalable and remotely manageable. And that, I think, is the greatest benefit, because our telcos also found out that once they launch their product in the market, people ask for new applications, and then it's very, very difficult with some proprietary architectures to provide that scalability, or very expensive.
Okay. Any more questions? Okay. Thank you very much for joining us. And
Thanks. Thank you.